아 진짜 이러면
Okay, gentlemen, are you ready?
봉사 kick it off. Okay,
Okay, what we're going to do is we're going to start talking about our next section. Okay, I hope we'll have 2 more sections left before the end of the year. Okay? It's the reality.
And 2 more tests.
Yes.
Yeah.
But they're kind of short sections. This one that we're going to start talking about is what are called polar coordinates. Okay, polar coordinates, a way to graph something. I need 1 volunteer. Homestuck, come here and help me. Now I want you to face this door. No, don't move. Stand right there. You're just looking for it. I want you to describe to me where, from you, what is your relationship? Where is your location relationship to Jason? What is Jason's location?
From me?
Yes.
Like, first, second, third.
No, just describe their location.
Go right, go left.
Hey, that's not you. Describe your location. Sit down. Ethan, I need your right here. I want you to same thing. Face the door and describe to me the location that Junho is to you. How far? Maybe a few feet directly to the right of you, or? Okay, good. Sit down. Same thing. Face the door from about here. Face the door, and I want you to describe to me where Angel is in relation to you. What is her location? Backwards, right. Okay, how far? A few feet. Okay. You can sit down. Now, I want you to think about how do we normally graph things? How have you, up to this point, how did you know how to graph things, how to describe their location? What graphing system did we use? What did you have to describe? The coordinates, right? An X and a Y. Now notice, other than Homestuck, who tried to guess what I was going to have him do, the other 2 described a direction, right, to the right, behind, a direction to them, and a distance, right? It's much more natural to do this. If a little kid, his ball goes somewhere out in the field and you ask him where it is, he doesn't say, go up 3 spaces and over 2 spaces, right? He would describe it in some direction. It's over to the left, right? That far away, it's over there, right? It's much more natural. This is what polar coordinates are. It's where now, instead of describing a right, or an X and a Y, we're going to describe a degree and a distance. Okay? It's funny that we don't learn this one first because it does seem much more natural. But the graphing is kind of a little tricky how we look at it. So let's look at what this means. If we looked at it in kind of our XY, right, in our coordinate system, we could describe a point by describing how far right or left it goes, right, and how far up and down it goes. Okay, but now what's going to happen is we're going to describe it by using from the center, from the origin. We're going to describe what is our angle and what is our distance. Okay, a little bit different way to think about this. And we're just changing how we're dealing with our graph. Okay, this piece of paper that I give you, just leave it on your desk for now. We'll use it in a few minutes. Okay, now something really important to write down in these notes. Notice originally we would write our point as an x and a y, right? Now what it's going to look like is an r and a theta. What do you think those two things represent? What is r going to be? The radius, right? How far away is it from the origin? And what is theta?
Angle.
The angle. Okay? Pay careful attention to the order, right? The r must come first. If you wrote it in xy and you wrote the letters backwards, it means something different. Same thing with this kind of system. You have to write the radius first and then the degree. An example of what this looks like. Okay, so here is our new graph. This is what our graphs will look like now, right? You notice it's a circle. You'll notice there's several circles in there, right? Giving us that distance of the radius. Just like with an x and a y, we always had some kind of marking of what the distance was. Usually you'll get those units, right? Maybe the radius of 1 and a radius of 2. This one here is a radius of 3, right? A radius of 4. But they're circular now as we look at the degrees. Okay, so if we want to find 2 pi over 4, what does 2 represent? What does it mean?
X value.
We can't say x anymore. We don't have an x.
R.
The r, how far away it is. So we start here at the origin. And always, when we go back in your mind to when we first started looking at these degrees, right? Standard position. We always go on this side, right along what you would think is a positive direction. So we go 2, right, to here. What else do we know about this point?
Angle.
Pi over 4. How much is pi over 4?
45 degrees.
45 degrees. Now notice this in your circle. You see how these are kind of closer together? These 3 lines. So this is 0 degrees. How much is this?
90.
90 degrees. What is this one here in the middle?
45.
45. What about these two?
6 and 30.
30 and 60, right? Those degrees that are really easy for us to work with. We don't have random lines in here. We don't need to put every single degree in here. We're really just worried about those common ones. 0, 30, 45, 60, 90, right? And then those in every part. So we go over 2. Okay, and then we need to go pi over 4, which is where? 45. 45 degrees, right? Right here. So this point, we put our dot there and label it as point A. Right. Our system looks a little bit different. We're not looking at x and y's, but we're going that radius in degrees. I want you to take a few moments and try to graph for me this point. Draw yourself a rough, you've just practiced drawing circles, so you should have some beautiful little graphs on your paper. Now remember, if you don't know what 2 pi over 3 means, how can you change it into degrees?
Times 180.
We can't just multiply by 180. We have to
And
multiply
by
by
pi.
180 over pi.
Yeah.
180 over pi.
Don't use bad.
find for point B? Where do we start? Find our radius. So we're going to go over 4. Remember, make sure you're going in the positive direction. 1, 2, 3, 4. Okay, so it's going to be somewhere on here. How far around this do we go? What is our degree measure?
120
How did you find that?
times 180 over pi.
If you don't know what this means, you can always change it by multiplying 180 over pi. How do I know it's 180 over pi and not pi over 180?
Because it's pi already.
We have to cancel out the pi, right? Make sure that you put them so they cancel out. Okay, then what else can I simplify here? 2 times 180 over 3. This will become a 60. So what is our degree?
180. 120.
120. Where is it going to be? Here's 90, here's 120. Right, our beats. Okay, I want you to graph for me these last 2 points. Put them on the same graph, that's okay. Make sure you label them.
So noisy.
It's okay if we're not perfect. When you're running between the square, that's not the case. It's a little harder to Guys, I know some of your circles look a little rough. Don't worry about those. In your notes, you'll have to draw them. If you had this on, we're going to have some practice later or on a test, you'll have that graph, so you won't have to draw it. So don't worry about if your graph itself looks a little rough. Okay, I think we're all. I want you to put C on the board, then do not come sit back down.
Right.
Do not come sit back down.
Cross. It's like what
Okay. Put D on the board, do not come sit back down.
kind of
Okay, as we draw this on the graph, I want you to check to see if you agree or disagree with them. Don't set that back down yet. We'll wait till Junho draws his.
What?
Wrong.
HBC.
I'm not so sure if these are right or not. I didn't check them.
Oh, right.
Iwan, explain to us how you put C on that graph.
What?
Iwan, explain how you got C.
Greater than 3, 1, 2, 3.
Okay?
And then 180 over pi divided minus 5, 3 pi over 2. That is 170. What are you asking? So here, 270 is
Good. Good.
Is that true?
Yeah. What did you do differently? What do you think you should do? Make sure for this one, it's a negative, right? We need to go in this direction. Our degrees always go around in the counterclockwise direction. Yeah, a positive degree always goes around in this. This is a negative 3, so we must go back 3, and then 270. Good. Just give me before you get right. Okay, Junho, explain yours.
Okay, so the radius for D is 1, so it's supposed to be over here in a circle, and then this is negative 225.
So what do you mean? So show us what you're doing.
I show you.
This is right.
Right. Good.
It's right.
Okay, so this one, right? Notice it's 1, so we go over 1 on our radius. What is this degree? A negative, which means we need to go in this direction around.
Yeah, I did like that.
Okay? Just like when we studied our standard position, right? Positive is going in that direction, negative is this way. Right? If it is a positive degree, which way do we go? Counterclockwise, Ivan, sir. If it is a negative degree, which direction do we go? Clockwise. Okay? This is your next challenge. I want you to look at these points. Ladies and gentlemen, listen to this direction. I want you to look at these points and find for me what are the coordinates. How would we describe this point A? What is it? What is its coordinates?
Do you have also negative 1?
If you wanted to.
It's only 1.
You just have to write 1.
Does that have to be like high?
No, if you want to use degrees, that's fine. The directions doesn't tell us if it's radians or degrees. You can use either one. I'm okay with that. Okay, if you have found your coordinates, compare with the person next to you. See if you have different answers, same answers. Why are they different? If they are different.
Exactly.
Yeah, I just did like
240. We can use negative and stuff.
Sure.
She said it doesn't say we can't
Remember, if yours are different than the person you're comparing to, why are they different?
Yeah. I'm not happy.
Oh. If you had it on paper in front of you, you'd be able to mark it. Okay, did you guys find that you all had the exact same answer as the person sitting next to you? Did you all have the same answer as the person sitting next to you?
No.
What could be different? You could have been negative, right? Be careful about this. As we talked about coordinate planes, gentlemen. I appreciate that you tried making that into a math song, but it's still, right now, it's not the right time. As we talked about our x and y coordinate, if we looked at a spot, we could only have one coordinate for it, right? There was only one x-y combination you could have to get there. In this kind of graphing, we could have gone positive, right? This D, for example. We could have gone 4, 0, right? Or we could have gone negative 4,
180.
180, or
Pi.
negative 4,
And pi. Minus 200.
negative 180, right? There's not just one way that we could have gotten there. So just because yours are different from the person sitting next to you does not mean that you did it incorrectly, okay? It just meant that you went a different direction, okay? But it's still correct. I don't want to see any of your answers. Now, to get to D, you could have said, okay, negative 4, and maybe you tried to make it really complicated, and you said, I actually went around 5 times and ended back here. Don't do that to get your answer, right? If you're trying